Okay, final example of this unit is example 10. So there's the velocity of the particle p, and it gives you the time. So let's start by writing that down. So part A, velocity equals, I'm going to put it in my favourite column vector format, 3t squared minus 8 on the I and 5 on the j. And it tells you that when t equals 0, the vector p has a respect to the fixed origin O is 2i minus 4j. Find the position vector. Right, so if we want to find the position vector, we're going from velocity to displacement. So we're going to integrate. So r is going to be the integral of v with respect to t. So I just need to integrate this vector, 3t squared minus 8 over 5 dt. So this is going to be 3t cubed over 3 minus 8t and 5t down here. And we have to have a plus c, but we're not going to write plus c, we're going to put it in two components, a p and q, so both bits have a constant added on. Then I can neaten this up. This is t cubed minus 8t all over 5t. To get p and q, all we have to do is look in the question for more information. So it tells us that when t is 0, the fixed origin will be 2i minus 4j. So I can substitute that in. I can say, well, let's see what happens when t is 0. We have that r equals, well, that's 0, 0 plus pq. And it tells me that that is equal to 2 minus 4. So this is 2 minus 4 must be pq, right? Because the 0, 0 dies. So it gives me a final equation for position vector r to be t cubed minus 8t plus 2 and 5t minus 4. Okay, that's the position vector of p after t seconds. Part B tells you about a second particle that has constant velocity, and when t equals 0, the position vector of q with respect to the origin is just 2i. Prove that p and q collide. Okay, so firstly, for two things to collide, we must have that they are in the exact same place at the same time. So for some value of t, I need to have that the I component and the j component on both of them is exactly the same. I've got the position vector for r, for the first one for p here, so I need to find a position vector for q first, and then we can see if we can find a point where they're at the exact same place at the exact same time. So for q, what we have is it moves with constant velocity, which means we can use that other formula from earlier in the unit, that r is going to be r0 plus vt. That's only for constant velocity, where r is the position vector and r0 is the starting point. So r is equal to the starting point, which is 2i, so 2, 0, plus v, which is constant, 8, 4, lots of t. So I put them together, write them as 1, it's 2 plus 8t and 4t on the bottom here. So what I've got is I need to solve these two equations here. This is p and this is q, and their locations. And I need at a certain time for them to be in exactly the same place together. So what we're going to do is we're going to solve them simultaneously. So we're going to find out what values of I, when are the values of I equal, and find the values of t, and when are the values of j equal, and find the t. So I need, for some value of t, from the j components, for 5t minus 4 to be equal to 4t. And for the I components, we need t cubed minus 8t plus t equals 2 plus 8t. Now obviously these are no good if I get two different values of t. I need the I and the j components to produce the same value of t, because that would mean they were in the exact same place at that same time. It's no good knowing that the i's components were both equal to 5, but one had j component minus 2 and the other had j component positive 2. They wouldn't collide, would they? They're not in exactly the same place. So let's have a look at solving these two equations. The first one here is straightforward enough, right? This is 9t equals 4. No, sorry, 1t equals 4, so t equals 4. When we rearrange that, move the minus 4t over and add the 4, so that's t equals 4. On this one, move everything to the same side. I get t cubed minus 16t is equal to 0, because the 2 and the 2 cancel. I can factorise this with an individual bracket. This is t squared minus 16 equals 0. This is when t equals 0, t squared equals 16, which gives me t equals minus 4 or 4. So what have we found out there? Well, they have the same I component after 4 seconds, and they have the same j components after minus 4 seconds, 0 or 4 seconds. The key is that after 4 seconds, they both have the exact same I component, they have the exact same j component, and therefore the two objects are going to collide. So the objects will collide after 4 seconds, and we can even work out the space by substituting the 4 in. So if I substitute the 4 into this, for example, this would be 2 plus 8 times 4, which is 34, and 4 times 4 is 16. So the objects will collide after 4 seconds at a location 34i plus 16j. Okay? So it's that idea that for them to collide, they have to be in the exact same location, so the I components have to match, the j components have to match, and that has to happen at exactly the same time, so the same value of t for both of those situations. Okay, that's the end of this lesson. It's actually the end of this unit as well, and it's the end of all of the the mechanics course for the A-level. So you've completed the mechanics A-level, well done. For this exercise, it's going to be exercise 8e, and again we can do the odds, do the evens if you feel like you need extra practice. The mixed exercise is also going to be useful now and accessible, and of course you could start to have a look at some mechanics past papers as well.